There we go. All right, guys. So today, let's start off with something I forgot actually last week. And has anybody come across an example of math in real life in the last couple weeks? Something that happened. Go ahead, Jack.
Well, my basketball game, my dad was converting the me and my dad were converting the fraction of free throws to a percentage.
Ooh, that's awesome. Very cool. See, it happens everywhere. It's all around you. You just have to kind of open your eyes and realize that you're using it. You're using math skills every day um, in a lot of different ways. This is a really cheesy example, but I was laying in bed this morning and I thought about how many Kleenexes I must use in 1 year because I use quite a few. And if I were smart, I'd probably buy stock in the company. All right, Tyler, why don't you share your example?
Okay, for my birthday this weekend, we went to the shooting range
Ooh.
and I shot a pistol at a target. It's right here. And I had to count all my shots and where they were placed and add up my total of points.
Oh, right. Okay, yeah. And add up your points because if you shoot closer to the target, then you get more points, and then if you're farther away, you get less points and that kind of thing. That's awesome. Anybody else? No? Okay. All right, well, we'll move on. Today is actually kind of a fun, little bit easier day. We are going to start off with a little brain pop video on mixed numbers, and that'll be fun. And then we'll actually practice adding and subtracting mixed numbers, which is what you're doing right now in your regular math class. But then we'll spend just a little bit of time reviewing a couple things that you'll see on your math final. Things like greatest common factor, least common multiple, adding and subtracting fractions, and so on. Okay, so looks like maybe we lost Jack, but he'll be back, I'm sure. There he is. Okay, sit back and relax. Let's start off with a fun little video.
Dear Tim and Moby, what is a mixed number? From Dino11. Well, a mixed number is made up of a non-zero integer and a fraction. 1 1/2, 2 3/4, 27 3/8. These are all examples of mixed numbers. Moby and I are working on a mixed number right now. We're supposed to add 2.5 liters of oil to the car. 2.5 really means 2 plus 1/2. Converting a mixed number to a fraction is just a matter of adding two fractions. Well, look at 2.5. To add 2 and 1/2, we need to write 2 as a fraction with a denominator of 2. 2 is the same thing as 4 halves. Now, adding them together is easy. 4 halves plus 1/2 equals 5 halves. A fraction like 5 halves with the numerator larger than the denominator is called an improper fraction. No, they're just called that. Oh, there's a shortcut for converting mixed numbers to fractions. Yeah, how much oil do we have left over? 3 3/4 liters of oil. The shortcut is to multiply the whole number by the fraction's denominator and then add the numerator to the result. We place that result over the denominator and get our improper fraction. So, 4 times 3, that's 12, plus 3 is 15. 15 over 4, 15 fourths. See, Moby? Mixed numbers aren't so tough. Moby?
Oh, jeez.
Maybe you should go easy on that stuff.
Okay. All right, let's take the quiz. All right, let's do the graded quiz, of course. And number 1. So you'll type into the chat either A, B, C, or D. So what is the easiest way to convert a mixed number to a fraction? Is it to multiply the denominator by the whole number, then add your result to the numerator? B, multiply the numerator by the whole number, then add your result to the denominator. So you need to know what a numerator and denominator is, for one thing. The numerator is the number on top in a fraction, and the denominator is the number on bottom. Or is it C, add the numerator and the whole number together, then place your result over the denominator? Or find the least common denominator of the whole number and the denominator, then multiply. Whew! It's a lot of words. Okay, so we have one answer. Good. All right, so most people are saying A. It'll tell us at the end if we're correct with everything. All right, so a recipe calls for 3 3/8 cup of flour. How can you express that mixed number as a fraction? So you might have to write it down, 3 3/8, and then I call it magic circle time. Okay, we got one answer. And we'll practice this more in a second, but very good. Hopefully, maybe you could even do it in your head. Most people are saying C. Sorry. 14/10 is an immodest fraction, an improper fraction, an unpopular fraction, or mixed fraction. Good, that was easy. How can you express the mixed number 2 2/10 as a fraction? Good. You guys could do this in your head. Perfect. Okay, so this is kind of what we are actually practicing in class. We are adding up 2 1/4 plus 3 1/4. Yay! A lot of this looks like mental math. Perfect. What is the mixed number 4 1/5 as a sum of two fractions? So basically, which of these two fractions would add up to be 4 1/5? Okay. Getting a couple different answers actually on this one. Okay, most people are saying A, so we'll go with that. Sorry, gosh. Convert the fraction 21/6 to a mixed number. So think in your head, how many groups of 6 will fit into 21? And then what would be left over? Good, TJ. All right. Most people are saying 3.5. What is 3 2/5 plus 2 1/10? Okay, so there we go, adding again. You might need to write these down. It's definitely not a race. I'm going to get a cough drop. Okay, so I'm getting a couple answers. Let's wait just a second for a few more people. Okay, most people have said D. All right. What is the mixed number that results from adding 3 halves plus 2 over 2, 2 halves? Okay. Awesome. What is the mixed number that results from 5/4 plus 2/8. So add them up and then make it into a mixed number. Oh, actually, this is a multi-step problem. You're going to have to change this into eighths before you can add them. Okay, most people are saying C. All right, let's see how we did. Yay, we did really good. Okay, so now we're going to actually spend a little bit more time practicing adding and subtracting mixed numbers. So here we go. Our first problem is 10 and 7/10 minus 2 and 9/10. Okay, so this is an example that I want to, oh, sorry, let me wipe my board clean. There we go. I'm going to actually do this one with you before I start setting you out on your own. Okay, there we go. So I see a problem here. The denominator is fine. That's fantastic. But I cannot take a 9 away from a 7. So I'm going to have to change this before I can subtract the 9. So basically, what I could do is just remember that you have 7, right? Take out another whole number. So take out 10/10. Change that to a 9, and now 10/10 can become, plus your 7 would be 17/10. So now I would be able to actually subtract and do the problem. Okay, so now my problem reads 9 and 17/10, that's a terrible 9, minus 2 and 9/10. So, I'm just kind of doing this with you. What's 17 minus 9? How about Tyler? What's 17 minus 9?
I messed it up. It's 8, not
Good.
6. I
That's fine.
calculated it. I did it as 8.
Oh, that's fine. Okay. And then what's 9 minus 2?
7.
Good. But now this is not simplified the entire way. So now I can reduce both of these if I divide by 2. So 8 divided by 2 is 4, and 10 divided by 2 is 5. So your last and final answer would be 7 and 4/5. Let me just back up to the part that was maybe somewhat confusing. This part right here. Does everybody see how I took out the whole number? I took out 10/10 and I changed this to a 9. And I added that 10/10 to what I already had, which was 7, so that I was actually able to subtract 17 minus 9. Does everyone see that? Just give me a thumbs up or down or sideways. Okay. All right, that's good because that's kind of what I wanted to make sure that you saw. All right, let's type that in. Yay! That's right, Dakota, you did this yesterday, and that's kind of why we're doing it now, practicing. 10 and 3/7 plus 7 and 3/7. I'm going to let you guys work this one out. Send me your answers in a private chat. That'd probably be best. Ten and 3/7 plus 7 and 3/7. Okay, good, good. I'm seeing a couple answers. Okay. Very good. So most people are saying 17 and 6/7. And that is correct. All right, let me just show you this one. Let's wipe my board. Here we go. Snap a picture. Okay, and our problem is 1 and 7/11 plus 5 and 10/11. So I usually add my whole numbers first. So 1 plus 5 is 6. And then 7 plus 10, we all know, is 17. And then, just keep your 11s. But I have a problem here. 17/11ths. There's a whole number inside of there. There's another whole one inside. So if I take out 11/11ths, what's 17 minus 11? Anyone? If I take out 11/11ths, go ahead, Tyler. Yes, 6. Perfect. Now, I took out a whole number here, so I'm going to add that whole number that I took out to my 6, and that would become a 7 instead. So 7 and 6/11ths is your final answer. Let's see. And there we go. All right, let's just keep practicing. 1 1/4 plus 7 1/4. This one's easy. Good. Very nice, Tyler. Good job, Jack. Nice, TJ. I'm going to wait for just a couple more people. You're close, Dakota, but what's 1/4 plus 1/4? Good, Kaylee. And Jeremy, make sure that you're going to try to go ahead and type something into the chat as soon as you get it. And you are correct. Most people, it says that it is 8.5. And oops, why is it not typing? There we go. 8 1/2. We know that 1/4 plus 1/4, you can think of that as like a pizza, and you got your fourth is one little triangle plus another little triangle, and that would be 1/2. So 8.5. Okay. All right. 3 3/8 plus 6 3/8. I'm going to show this one because there's kind of a multi-step again. All right, so I got 3 3/8 plus 6 3/8. Let's just take care of our whole numbers first. Everyone just show me with your fingers because you have enough. What's 3 plus 6? 9! Yay, fantastic. Now the easier part. What's 3 plus 3? 6. And then, of course, just keep your eighths. But I'm not done. This is the multi-step. I have to reduce this. Both of these numbers can be reduced if I divide by 2. So if I divide 6 by 2, I get 3. And if I divide 8 by 2, I get 4. So that would be the best and final answer, 9 3/4. Okay. Perfect. All right, they're giving us a lot of addition problems, but that's okay. I want to see from Jeremy this time. Make sure that you try this one, okay? 4 3/5 plus 1 1/5. When you get an answer, type it into the chat. Beautiful, Jack. Beautiful, Tyler and TJ. You guys are fast. This one is not a multi-step problem. This one's pretty easy, actually, because I can just add my 4 plus 1, which is 5. Why is that not typing? There we go. And then 3/5 plus 1/5 is simply 4/5. I cannot reduce 4/5. So final answer, there we go. All right, finally, a subtraction problem. 11 minus 1/4. This should be mental math. Very nice, Tyler and TJ and Jack. Great job. Okay, I'm gonna show this one because you might have to change it, change that 11 so that you're able to figure it out. If you're looking at this and you're like, well, I really don't know what to do. This is not a fraction. You can change it to a fraction and make this 10 4/4, right? Because 10 and 4/4, if I simplify it, I know that 4/4 equals 1. And so if I simplified it, that would equal 11. So 10 and 4/4 minus 1/4, well, 10 minus nothing is just 10. And then 4/4 minus 1/4 is 3/4. Okay? All right. 10 and 3/4. You guys are fast. Just take some practice. Oh, here's another good example. 6 minus 10/11. If you need to, change this to 5 and 11/11. And if you change it to 5 and 11/11, then you can subtract 10/11 pretty easily. Good, Kaylee. Nice, Jack. Let's give everyone just a second. Good job, TJ. All right, Jeremy. Okay, so 5 and 1/11 looks like my final answer. Yay! All right, let's do a few more subtraction problems. 9 and 1/9 minus 4 and 7/9. I'm going to show this one again because it's another multi-step type of problem. Okay, hold on. Okay, so looking at it again, I cannot take away a 7 from the 1, so I'm going to have to change this number first. I can change this. I can take out a whole number from that 9. I could take out 9/9 and add it to 1/9. And if I take out 9/9, that would become an 8. And 9/9 plus 1/9 would be 10/9. Now I can do the subtraction pretty easily. 8 minus 4 is 4. And then 10/9 minus 7/9 is 3/9, which can also be reduced. 3 goes into itself once. 3 goes into 9 3 times. So my final answer is 4 and 1/3. Hopefully they'll give us another one like that so you can do it this next time. And of course not. This one's easy. 10 and 1/3 plus 1. Woohoo! All right. Yeah, all you have to do is just add the 10 plus 1 and keep the fraction the same. So it would be 11 and 1/3. Yay! All right, here we go. 16 and a half minus 9 and 1/6. Here's the problem. Well, it's not really a problem. I'm going to have to make this into, a multiple of 6 because I can't do this problem without changing the denominators. So let's do that. I guess if you just keep going on it, it gets a little harder each time, which is good. Okay, 16 and a half minus 9 and 1/6. I'm going to leave my 9 and 1/6 alone. And I'm going to change 1/2 into a portion of 6. So how many times does 2 fit into 6? 3 times. 3 times 1 is 3. So now I can do the problem pretty easily. 16 minus 9 is 7. 3/6 minus 1/6 is 2/6, which can be reduced. 2 goes into itself once. 2 goes into 6 3 times. So my final answer is 7 and 1/3. Is that what everybody? Yep, that's what everybody was sending me in the chat. Fantastic. Okay. All right, this one's all you. 8 2/3 plus 8 1/6. Notice we have that same issue with the denominators that you need to change. Okay, I got one answer. What do you want, kitty? You need to go away. What do you want? Okay, got a couple answers. Looking good, Tyler. Looking good, Kaylee and TJ. All right, good job, Jack. Jack, why don't you talk me through this one and tell me what you did to come up with that answer? Because it's correct.
Okay.
So what
So
was
what
your
I did
first step?
was well, my first step was I need to get I need to get equivalent denominators.
That's
So
right.
what I did is my doubled 3, which was 6, and I had to double 2, which was
Okay.
4.
Good. So you changed this to 8 and 4/6, which is
Yeah,
equivalent to 8 and 2/3. And if you're working with sixths and a sixth, then it's easier to add up.
yeah,
Perfect. Okay. And then of course 8 plus 8 is 16.
yeah.
Yeah. Good. All right. Here's another one of those problems where I'm going to have to take out a whole number. I'm going to have to take out 4/4 and add it to 1/4. So this will become 9 and 5/4 minus 8 and 5/8. Oh, wow. And oh, wow, this is a totally multi-step problem here. Okay. Sorry, I wasn't even looking at the denominators. They're different. Let's just work with the denominators first. Change this into 2/8. Okay. So yeah, go ahead and write this one down. This one might take you just a second. Good, Dakota. I'm sure you can. And you're going to be the one to talk us through it then. I'm going to wipe my board clean and okay, when you get an answer, type it into the chat. Oh, kitty, you just need to get down on the floor because you're in my way. Very nice. I'm seeing some correct answers show up. Dakota, talk me through my first step. I'm going to have to change this into eighths. Are you there?
If I
Okay.
yeah, if I remember correctly for this one, um, you bring the 10 over, make it a 9.
Oh yeah, well right now I'm just working with getting the comma denominators. I'm not
Oh,
quite to that step yet. I know what you're talking about though. So 4/8, how many fours fit into an 8? 2. 2 times 1 is 2. So 1/4 is equivalent to 2/8. So now I have that step of taking out a whole number. So now I'm going to take out 8/8. So that becomes a 9. And I'm going to add 8/8 to 2/8. Now I'm able to do the problem because I have numbers that are same denominators and I can take 5 away from 10. So 9 minus 8 is 1. And there we go. Perfect. Okay, that's what I got from most people in the chat. Yay! All right, let's try this one. 8 minus 2/5. Remember what I said, you can change 8 to be 7 and 5/5. Good, Jack. Very nice, Kaylee. Okay, good job, TJ. Okay, I've got the answer from most people as 7 3/5. So, Kaylee, can you tell me how you got 7 3/5? What was your first step? Make sure your microphone's on. Anybody? Kaylee, do you want to explain? You got the correct answer. Oh, all right. Her microphone's not working. Jack, go ahead and tell us what you did.
So what I did was I converted 8 to 7 5/5.
Yep.
Then from that I did 5 minus 2, which was 3. Then I got 7 3/5.
Perfect. Easy enough. All right, guys. I think we're doing pretty good on this skill. Give me a thumbs up if you feel like we can maybe move on to something a little harder. Maybe? Sorta? Okay. All right. And if you need extra practice on this, you know, don't hesitate to email me and I can definitely set you up with some extra practice on adding and subtracting fractions, mixed numbers, the whole bit. But we're going to move on to something that's slightly harder, and we're going to watch a little video on exponents, and then we're going to work with adding and simplifying exponents. So this video, it's going to kind of talk about something, it's going to talk about negative exponents, which I don't think you guys have had any exposure to yet, but that's totally fine. Eventually you will need to know about negative exponents. So a little exposure to it won't hurt you, and here we go.
I knew we should have turned left at the last artery. I will turn this submarine around, mister. Dear Tim and Moby, how do I use exponents? From Claire. Thanks to Moby's shrinking machine and my bad sense of direction, it looks like we're stuck here for a while. So, let's talk exponents. An exponent is just another way to show repeated multiplication. Take the number 125. We can get this number by multiplying the number 5 by itself 3 times. So let's write it as a product of its factors. 5 times 5 times 5. 125 is what we call standard form. In exponential form, it would be 5 raised to the third power. 5 is our base number, and 3 is our exponent, which basically tells us how many times our base is being multiplied by itself. Sure, they're useful, especially for... Whoa. Yeah, that was pretty intense. How many white blood cells do you think were in that wave? Let's check the ship's sensors. Ah, good. This will illustrate my point perfectly. Like I was saying, exponents are useful for writing numbers that are really big or really small. 16,384 is a pretty big number, and sort of a mouthful to say. It just so happens that we can rewrite it in exponent form as 2 to the 14th power. If you multiply 2 times 2 times 2 times 2 times 2 and so on up to 14 twos, you end up with 16,384. Right, well, those are positive exponents since they deal with positive numbers. There are also negative exponents. It's exactly what it sounds like, an exponent that's a negative number. While positive exponents give us really big numbers, negative exponents give us very small numbers. Let's take the distance we've traveled along the blood vessels of this body. Although it seems like we've been trapped in this sub forever, we've really only traveled a grand total of 8 millimeters. Well, what do you expect? We're microscopic. Millimeters are pretty small, so let's convert our distance traveled to a unit we're more used to dealing with, meters. There are 1,000 millimeters in a meter, so 8 millimeters is equal to 8 1,000ths of a meter, or 1 1/25th. Okay, remember how we said the exponent form of 125 is 5 to the third power? That means we can rewrite 1 over 125 as 1 over 5 to the third power. And here's the really neat part. A positive exponent in the denominator of a fraction is actually the same as a negative exponent, only with the base in the numerator, which means 1 over 5 to the third power equals 5 to the negative third power. So all you need to do to switch between positive and negative exponents is to take the reciprocal of the base. Good point. With really, really big numbers or really, really small numbers, it's probably a good idea to use scientific notation, a way of writing numbers that raises factors of 10 to different powers. Check out the scientific notation movie for more on that when you get a chance, but right now let's grab this red blood cell. According to the ship's database, the average human body has about 5 million red blood cells per cubic millimeter of blood. Instead of writing out that huge number as 5 plus 6 zeros, we can convert it to scientific notation. Care to guess how big each red blood cell is? The average red blood cell has a diameter of 7 microns, which is equivalent to 7 1/millionths of a meter. We can convert that to scientific notation too. See, it's much easier without all those zeros. Now, we can only find our way out of this body.
Oh boy.
This ought to be interesting.
Oops. Sorry. Okay. All right, let's get rid of brain pop. There we go. All right, so that, took it a little bit farther than you guys have been exposed to with negative exponents, but you have had some exposure to positive exponents. So we're going to practice simplifying some positive exponents because that is one thing that you'll see on your final. So go ahead and write this one down with me. If I say, let's just start off real simple. 6 to the third power, what I mean is 6 times 6 times 6. Go ahead and find that answer, which would be called standard form. Good. So what you would do first is find 6 times 6, which is 36, times 6. And I think you just added up wrong, Jack, because the answer would be 216. All right, let's practice another. If I say 2 to the fourth power, what I mean is 2 times 2 times 2 times 2. Go ahead and find that answer, which would be simplified standard form. Yeah, that one's probably mental math. Good. Good. Good, everyone. 2 times 2 is 4. 2 times 2 is 4. So 4 times 4 is 16. Fantastic. So to take it just one step further, if I say simplify 6 to the third power divided by 2 to the fourth power, what you should do is you've already told me what these answers are, basically. 6 to the third power is 216 divided by 2 to the fourth power, you've told me is 16. So now I can definitely simplify this. I know that 2, I'll let you work on it. 2 is a factor of both of them, but you go for it for a minute. Try to find the simplest form. Good, TJ. So I'm just going to show you a couple different ways you can do it. When you look at fractions like this, you need to recognize that it can be a division problem, and this number would always go underneath your house. So here's one way to do it, or I can simplify it first to make it smaller numbers, and then I can, probably do it mentally, actually. So what's 16 divided by 2 is 8. 216 divided by 2 should be mental math. But in case it's not, I'll just kind of show you. Now that's even easier to simplify. Could put 108 underneath the house and do that division problem. Okay, so I've kind of shown you two ways. You can just go ahead right away and divide, or you can simplify and then divide with some smaller numbers. So go for it. I'm going to clear my page actually, and I'm going to use this slightly simpler division problem. Okay. Okay, Tyler, I'm sorry you got kicked off, but here we are. We're just basically doing a division problem. All right. So I know you guys have, done this for years, but just to remind you, does McDonald's serve cheeseburgers? Those are the steps to division. Divide, multiply, subtract, check, bring down. Okay, so 8 goes into 10. I'm doing the division part first. Once, multiply. Third step is to subtract, bring down. How many groups of 8 fit into 28? Go ahead and hold up your fingers. 3. Second step is to multiply. 3 times 8 is 24. Next step is to subtract. So there we go. You are left with 13 and 4/8, which can be obviously simplified to 13 and a half. Okay. All right, let's look here and just do just a couple more exponent type problems. Out of everything on your final exam, those are probably the hardest. Let's see, that's not what I was looking for. Oh, hold on. I have to go to the topics. Okay. Where did I find it? No. There's so many. Oh, geez. Okay. It would be under. Oh, it'd be under exponents. How about that? Okay. Here we go. Simplifying expressions. Okay. First problem we have is 11 to the second power times 7 to the second power. So find this answer first, then multiply whatever this answer is. So order of operations, you always do your exponents first. Okay, so I'm going to take a picture of this one. And snap. Okay, so I'm going to walk you through it just in case you're struggling. 11 to the second power is kind of like saying 11 times 11. So what is 11 times 11? Go ahead and type 11 times 11 into the chat. Good. 121. 7 to the second power is kind of like saying 7 times 7. So what's 7 times 7? We all know is 49. So here is your problem that you need to actually be working on. 121 times 49. Go for it. Very nice, TJ. Okay, I think you're just one number off, Kaylee. Make sure you add it up correctly. So basic multiplication. Okay, good job, Tyler. So I'm getting 5,929. Yay! All right, this one's pretty easy. 4 to the second power times 4 to the second power. In your head, you should know what this is right away. That's 16 times 16. Very nice, Jeremy. Okay. I think you're just adding up just a little bit off, Jack. So 16 times 16, because 4 to the second power is 16, and 4 to the second power is 16. 16 times 16 is 256. There we go. Okay, so here's what I was showing earlier. I'll take a picture. Yeah. Clear. And snap. Okay, 12 to the second power divided by 3 to the second power. Order of operations, guys. Remember that. Please excuse my dear Aunt Sally. Parentheses, exponents, multiplied, division, addition, subtraction. That's your order of operations, what you do first all the way to last. So first is exponents. 12 to the second power is like saying 12 times 12, or 144, divided by 3 to the second power is the same thing as saying 3 times 3, or 9. So now that is your final problem. This is a division problem. Recognize fractions are division problems. 144 under the house, 9 on the outside. Go for it. Good, TJ. You're fast. Nice. Kaylee, check your work. Good job, Tyler. Awesome, Jeremy. And that is correct. If you work out the entire problem, go through it, bring it down. How many groups of 9 fit into 54? 6, and boom, you're done. 16 is your final answer. All right. Okay, guys, so that was probably the hardest thing that you'll be seeing on your final is simplifying exponents. You'll see a little bit of everything that you've been working on, like adding and subtracting fractions, multiplying fractions and that kind of thing. So are there any other questions before I let you go for today? No? All right, turn on your webcams and tell everyone goodbye. And Dakota, if you want to stay on and tell me your thing with Sketch, that'd be cool. But everyone else, you are welcome to go. Oh, go ahead, Tyler.
Whenever we made our science projects, like quite a few weeks ago,
Oh yeah.
are we still going to present them or not?
I don't think so. No.
Oh,
I know. Kind of a bummer.
okay.
But we just don't have time. Math and reading are, I don't want to say more important, but yeah. Okay. All right. Say goodbye, everyone. Bye. All right, Dakota, what do you want to show me?
Okay. On math that I did yesterday,
Uh-huh.
there's like, can I show you on the sketch thing?
Oh, sure. Do you have Sketch on your computer?
Yeah, but I don't know how to send it.
Okay, I'm going to make you the presenter so I can see your screen.
Okay.
So it's going to say something like make me presenter and just click on that. And then, yep, okay, now I can see your screen. Perfect.
Hold on, my screen is on. Alright, so for example, one of my problems was 3 and 1/4.
Okay.
And me and my mom did 3 and 1/4 minus 1 and 1/3.
Okay.
And so me and my mom did this one times 3
Yep.
and this one times 4.
Right, to make it into 12ths. Right.
Right. And then me and my mom brought the 3 that's right here over here.
Okay.
And then we went like this.
3 and 3/12ths. Yep.
Then for the bottom one, it was 1 and 4/12ths.
Yep.
And so then we did the 2.
Yeah, taking out the whole number from that 3 and 3/12ths and making it.
Then we yeah. Then we had to turn this 3 into a 2. Then we did 2 and 12/12ths plus 3/12ths.
Yep.
Then we added it up and it became 2 and 15/12ths
Yep.
minus 1 1 1 1 and 4/12ths. Then we got our answer of 1 and 11/12ths.
Okay, 15/12ths minus 1. I'm doing this with you as we do it. Okay, yeah, so it should be 1 and 11/12ths. That's exactly right.
And that's how we did one of the problems.
That's a perfect example of how you're supposed to do it. You needed to change, your first step was to change it into common denominators, and so you used 12ths. And then you had to take out that whole number and change it to 2 and 15/12ths, and that was your second step. And then you were able to actually do the subtraction. That's perfect.
right, and then for one of the other problems, it was an addition, so we did 2 and 1/3 times 22, which equaled up to 2/6.
Okay.
Plus 2 and 1/3 plus 1 and 1/2
Yep.
times 3 for the bottom.
Yep.
Then that came out to be 1 and 3/6, and it wasn't times 22. It was times 2.
Times 2. That's, yeah.
And then we did it. Then I think we added it all up.
Yep.
We left the denominators. We added 3 plus 2, and for the fractions and for the whole numbers, we added those, and we came up with 3 and 5/6.
And that is exactly right. I've been doing it with you at the same time. Good job. So do you have a question, or did you just want to show me how awesome you are?
I wanted to show you that so that way I could show you what I learned yesterday on math, so that way
Perfect.
you know that I wasn't trying to get confused and all that.
Oh, well, that's fine. Yeah, that's great. And I'm so glad that you were able to show me and walk me through it. And I can see that you understand it. So that's perfect. Yay. Let's see. I'm going to try to, yeah, see, I've been doing it with you the whole time. And you got it exactly right. So good job, Dakota.
Okay, I'm gonna find the control pad thing, wherever it is.
Oh, yeah, I took the screen back. Sorry. So I can't see your screen anymore. But, well, I hope you have a good rest of your day.
Okay.
Yeah, I'll talk to you a little later, okay?
Okay.
All right, bye Dakota.
Bye.